Hello, Coach Travis here with another trigonometry video. Sorry, sometimes I get confused about what I'm doing. So, alright, so we got a problem here. The question is, if the terminal side of angle A goes through the point negative 24, 25, 7 25ths on the unit circle, then what is the sine of A? Alright, so let's try to draw a picture of what this looks like, because I like pictures. So it says that the x-coordinate is almost negative 1. 24 25ths is almost negative 1. So it's going to look, maybe something like that. Maybe it's an approximation. Okay, and so then what they're telling me is they're telling me that they're telling me the x and the y coordinates of that point. So they're telling me that the x coordinate is negative 24 over 25 and the y coordinate is 7 over 25. Now, those are the coordinates of that point right there. And so, alright, so then basically this question is just a question of, do you know the definition of sine and cosine, the unit circle definition of sine and cosine? Because the unit circle definition of sine and cosine it tells us the answer to this question right away, because the idea is that the unit circle definition of sine and cosine says that the x-coordinate, that is the cosine of the angle, and the y-coordinate, that is the sine of the angle. So answering this question should be a piece of cake. We just say the answer is going to be 7 over 25, because 7 over 25, that is the y-coordinate of the point that we're given on the unit circle where the terminal side of the angle crosses the unit circle. So that's our answer to this question. All right, now we got a slightly different problem here. I just changed the question on you. So this question, determine the exact values of sine of theta and cosine of theta given that the terminal side of the angle theta intersects the unit circle in the first quadrant at the point 4/15 comma y. Okay, so they tell us it intersects in the first quadrant. So my angle should be over here somewhere. And I guess 4/15, that's about at 1/3. So if the x coordinate of that point should be about 1/3. So just eyeballing it, maybe that looks like the x, if here's x is equal to 1, so that could be x is equal to 4/15. Alright, so down here is this is the angle theta. And then, alright, so they're telling us the coordinates of this point. So that's handy. So the coordinates of that point are 4/15 and y. Okay, so from the previous problem, we know that half of our work is done already. Half of our work is done, that we know that the cosine of theta is going to be 4/15, because the x-coordinate of the point where the terminal side intersects the unit circle, that is the definition of the cosine. Okay, but the problem is we don't know, I guess we could say it would be correct to say that the sine of theta is equal to y, because the sine of theta is the y-coordinate of where the terminal side intersects the unit circle. But I don't think that we can say more than that. Because I think if we think about it for a little bit, we can actually figure out what this value of y is. So we can do better, even though that what we wrote there is correct, but we can do better. We can be more specific. So yeah, and indeed, how are we going to be more specific? Well, the way we're going to be more specific is we're going to use the Pythagorean theorem here. What I see here is see if I can draw a straight line. I can drop a perpendicular down from the point to the x-axis, and so now I have a triangle. I'll highlight the triangle in green here. So we've got a right triangle right there, and I know that, what do I know about this right triangle? Well, I know the hypotenuse is 1. And the reason I know that is because the hypotenuse of this triangle is a radius of the unit circle. And the unit circle has radius 1. And then the other thing I know is I know this side of the right triangle is 4/15. Because this side of the triangle is the x-coordinate of that point. And the problem tells me the x-coordinate is 4/15. And then the height of this triangle will be y, because the height of this triangle is the y-coordinate of that point. But now you can probably see how we can use the Pythagorean theorem to figure out what y is. The Pythagorean theorem tells us that y squared plus 4/15 squared is equal to 1 squared. And so that tells me that y squared is equal to 1 minus, well, let's think about this. Can I do this in my head? I think I probably can. 4 squared is 16, and 15 squared is 225. So it's 1 minus 225, or 16 over 225. And I can even simplify that some more if I want to, because 1 is the same as 225 divided by 225. And that's minus 16 over 225. And now let's see, the hardest part here. What's 225 minus 16? Like 209? So that's 209 divided by 225. So that's what y is equal to. So right here, I could do the correct answer over here is 209 over 225. Oh, wait a minute. Wait a minute. No, I made a mistake. I I hope you caught it. Let's erase that. Because what did I forget to do? What I forgot to do is notice this is y squared. This is y squared. So, I shouldn't have erased what I wrote, because what I wrote was almost correct. But what I really should write here is it should have been 209 over 225. So that was half right. But what I forgot is there should be a big old square root here. Because we need to do the square root of all of that, because we figured out what y squared was. And then and we should be careful about this, that whenever you do the square root of both sides of an equation, you do have to introduce a plus or minus. Remember that? So but notice I don't have a plus or minus here. And you might say, yeah, Travis, why don't you have a plus or minus here? And the answer is, well, because we know that it's a plus. I mean, from the picture, we can see that y is going to be a positive number. So we're going to have the positive of the square root. So that's how we know that it's just the positive.